In the figure to the right, the equation of the solid curve is y equals cosecant squared x over 2, and the equation of the dashed curve is y equals 2 sine squared x. Determine the area of the shaded region. Okay, so the first thing we want to do on this problem is find where these two graphs intersect. We need x values. Okay, so we need to set these equal to one another. So let's set 2 sine squared x equal to cosecant squared x over 2. Now note that cosecant squared x is the same thing as 1 over sine squared of x. Okay, so this is 2 sine squared x equals 1 over 2 sine squared x. Okay, so we can multiply both sides by the sine squared x, and we will get, let's see, 2 sine to the fourth x equals 1/2. Okay, divide by the 2, so we get sine to the fourth x equals 1/4. Okay, and if we take a fourth root of both sides, okay, so that's going to end up giving us, let me go over here, I'm running out of room. It's going to end up giving us sine x is equal to 1 over root 2. If you rationalize the denominator, that's equal to root 2 over 2. Okay, so that's the solution to the equation. Now, in order to find out what that means for x, because it's solved for sine x, we're going to have to look at a unit circle. So if we go to the unit circle, this is something you should have if you're in a calculus class. You should have this handy. Keep in mind that this thing is cosine theta, comma, sine theta. Some of them don't show that. So the first values are the cosine, where the cosine equals those values, and the second number is the sine. Okay, so as you go around the unit circle, you look for the root 2 over 2 in place of the sine, and you see it right here. Okay, and then if you keep going, you see it again right here. Okay, so at pi over 4, or 1/4 pi, but pi over 4 and 3 pi over 4 are the first two solutions, and those are going to be the ones we use here. So we'll say x is equal to pi over 4 and 3 pi over 4. Okay, so that gives us our solutions, which would be our limits of integration. Now we want to actually integrate this thing. So what's our top function? Well, our top function is the sine function. You can tell because it is it's going up and down, and then the cosecant is the u-looking function. So the top function is going to be the sine function, and the bottom function will be the cosecant squared. Okay, so limits of integration, pi over 4, 3 pi over 4. Okay, and then we have 2 sine squared x minus cosecant squared x over 2 dx. Okay, so the cosecant squared, that has a antiderivative of cotangent, but are actually negative cotangent since it's already negative. But this one doesn't have one readily available, so I'm going to let's go over here and let's recall that we have a trig identity that lets us do this. Sine squared x equals 1 minus cosine 2x over 2. We can substitute that in. Remember, there's still a 2 here out front, but we can substitute this in for sine squared x. That should make our life a little easier on that. So let's write the problem again. 2 times 1 minus cosine 2x over 2 minus cosecant squared x over 2. Now the 2's here will cancel. Let's not forget to put our little dx. I'm bad about that. Okay, so we can now take this integral. This is just going to be 1 minus cosine 2x. That's a quick little u substitution for that. I'm not going to go into that. But the integral for this is going to be the 1 turns into x. The negative cosine 2x will turn into sine 2x over 2. Again, that's a u substitution. And this one, the negative cosecant squared x over 2, will turn into cotangent x over 2. And we'll take our limits of integration, power 4 to 3 pi over 4. Okay, and you can plug these in. I'm running out of time in this problem, but you plug in the top limit, put it all in, plug in the bottom limit, put it all in, and you should get an answer of pi over 2.